Hi, this is Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. And today, in our video lecture series, we are going to discuss about the source transformation technique. So, this topic comes under the Unit 2, Network Theorem and Source Transformation. So, come, let's get into the topic. So first thing, what is source transformation? So by the name itself, we have source transformation. So we are in the first unit and as well as in second unit, we are talking about the sources. So different types of sources that literally means that current source and the voltage source. So from that term, source transformation, we can able to define the term, right? So source transformation means that the current source to voltage source and the voltage source to current source transformation. This is called a source transformation simple in the simple ways. So according to this concept, so source transformation technique is very useful for simplifying the networks or circuits with practical sources. Whenever there is a possibility and requirement to apply the source transformation technique for the given circuit, then by applying this technique first and then use any of the method of analysis based on the requirement so that we can solve the network theory problems easily. So in network theorem, we have several methods that we are using, Norton theorem, Thevenin superposition, etc. So at that, when you are using the network theorem, we can use the source transformation also to simplify the network even simple. Okay, so that's the purpose of source transformation. So this technique, the source transformation technique or the method of transforming one form's source into other is known as a source transformation technique. The basic analysis method for any electrical network or electric circuit or nodal analysis and mesh analysis. So there are two types of practical sources. One is practical voltage source and practical current source. Hence, we can apply the source transformation technique for these two sources to convert uh, into each other. There are two source transformation technique used, practical voltage source into practical current source and practical current source into practical voltage source. So, practical voltage source into practical current source. So, what is practical voltage and practical current source means? So, theoretically, when you study the sources, current source or the voltage sources, we actually ideally we take the voltage value as it is and the current value as it is. But the practically, when you use the equipments in and circuits, that has some internal resistance. So internal resistance with the voltage and the current source is called a practical voltage source and the practical current source. So that's the difference between ideal voltage source to ideal voltage and current source to practical voltage source and current source. So here the practical voltage source is nothing but an ideal voltage source in series with the resistance. A practical current source is nothing but an ideal current source in parallel with resistance. Okay, the following figure shows the conversion of practical voltage source into practical current source. So here you look at the circuit diagram. Here in the left hand side, okay, we have Vs. So that is nothing but a practical voltage source and series with the resistance. Okay, so whereas the right hand side, by using the source transformation technique, we have converted this Vs into Is. And what about this R? The R here is series connection in the case of voltage source, but in the case of current source, it must be parallel. So this is the practical voltage source to practical current source conversion. So this we applied the source transformation technique for the independent practical voltage sources. Okay, independent. That means the excitation should not be given by the other equipment or the other circuit. Right, the energy should be delivered by the same equipment itself. That is called an independent source. Similarly, we can apply the source transformation technique for the dependent practical sources also. So here, after applying the source transformation technique, so the equation will become like Is equal to Es into R. The resistance value will remain the same in both circuits. The voltage at the open circuit terminal of the both circuit is same. In both circuits, the current will be same if the end terminal have shorted each other. So the practical current source into practical voltage source. So the previously we converted the practical voltage source into practical current source by using source transformation technique. Let's apply the source transformation technique for converting a practical current source into practical voltage source. The following figure shows the conversion of practical current source into practical voltage source. So here we have IS parallel with R, and when you convert into the practical voltage source, so VS, the IS will convert into VS, and we have one series resistance. So that is the difference. And here again the term, the circuit expression itself, that will be changed. Vs equal to Is into R. The resistance value will remain the same in the both circuit. The voltage at the open circuit terminal of the both circuit is same. In both circuit, the current will be same if the in terminals have shorted each other. Thank you.